Okay, let's talk a little bit about precipitation reactions. Precipitation reactions are often categorized as double displacement, or some people use the phrase double replacement reactions. In a precipitation reaction, two aqueous solutions are mixed together, and you can notice here we have potassium iodide, and then we have a lead 2 nitrate solution, and they're both colorless. And they're mixed, those two aqueous solutions mixed together, and upon mixing, a precipitate, an insoluble solid, is formed. Okay, that's what a precipitate is, an insoluble solid. And you can see it happening here. It's this beautiful, bright yellow compound called lead 2 iodide that is forming here. Okay. In a precipitation reaction, what is happening is the ions are coming into the solution. Okay, so we've got the potassium in the iodide solution, and we've got the lead with the +2 ion and the nitrate ions. Okay, those ions are present, and upon mixing, the positive cation and the negative anion can potentially stick together because the opposite charges attract. And if those oppositely charged ions attract and they're insoluble in water, then immediately they form a precipitate. Okay, and oftentimes the precipitate is a very bright color. It may be yellow, it may be blue, it may be white, but it'll be an obvious solid that is forming. Okay. The remaining ions that are still soluble in water, like the potassium ion and the nitrate ion, those we often define as spectator ions because they are not participating in the formation of the precipitate, of the insoluble solid. So let's take an example. Okay, let's try one here. Okay, these are our two aqueous solutions. We have a lead 2 acetate and a sodium sulfate solution, and we mix those together. Now, these are aqueous solutions, so these ions are already in existence. The lead with a +2, the acetate ions are there with their -1. Okay, so those ions are there, and this acetate, we have 2 of them that are present. And then we have the sodium ions, and we have 2 of those. And we have the sulfate ion present as well. So we mix these two solutions together, and our possible products, the products that could potentially form, would be the sodium ion go with the acetate ion. -1 charge, +1 charge, so they would combine in a 1-to-1 ratio. That's a potential precipitate. And the other potential precipitate would be the lead with the +2 charge going with the sulfate. Okay? So these two compounds are our potential precipitates. One may be a precipitate, both may be, or neither. But we need to check a solubility table. So first thing we do is we get us a solubility table, and this one is a common chart or flow chart that's shown in many chemistry textbooks, and we look up the two potential products. Okay, so let's first look up this sodium acetate. Okay, so we're looking for sodium and we're looking for acetate. So compounds that are mostly soluble, we follow this flow chart. Okay, there's sodium. Okay, compounds containing sodium are soluble. And we also notice there's the acetate ion. So they're soluble. So this right here, sodium acetate, is a soluble product. So this is not the precipitate. This is not precipitate. It's not participating in the precipitation reaction. Now let's check for the lead 2 sulfate. So we go back up here, we're looking for either lead or sulfate. Here we are, compounds that are mostly soluble. Sulfates are mostly soluble. It asks us, does the compound also contain strontium, barium, the lead 2, or the calcium ion? Yes, ours has the lead 2 ion. Yes, it does. It is insoluble. This is an insoluble product, which is our precipitates. Precipitates are insoluble solids. Okay, so these solubility tables, and you'll find these looking in a different arrangement, a different color scheme, will be found in any chemistry textbook, and it will help you find those compounds that are mostly insoluble and those that are mostly soluble, and we just follow looking for the ions that compose our compound. Okay, so if we wanted to write the equation here for this reaction, we would have lead 2 acetate plus sodium sulfate yields the PbSO4. Okay, this was our precipitate, our solid, and then the sodium acetate is still in aqueous form. Okay, it is still aqueous. And if we notice here as well, this equation is not balanced. So we need to put a 2 right here to balance the equation.